Hello everyone, my name is Virendra Singh Rathod and welcome to my YouTube channel. Today we are talking about another problem, number of islands. It's a very important and very easy problem. So let's understand this. So given an M cross and 2D binary grid which represents a map of one is land and 0 is a water, return the number of islands. Okay, an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are surrounded by water. Okay, so let's understand. So we'll understand with a small example here. I have drawn one example here. So let's see. So what the question is saying, basically question is saying question is saying, if you see there is a one here, this one can be connected in four directions. Vertically, horizontally means like this, like up and like down. So all four directions. So this one is connected to this one. Okay, and then this one is connected to this one. Okay, but this is diagonally, so this cannot be considered into this island. So this becomes one island. So this is one island. Okay, and if you see this one is not connected to anything, but this is also one, so this is one more island. So this is one and this is one, so total two island in this example. Okay, so let's understand how we are going to solve this problem. So let's do this. Let me erase these things. Okay, so let's understand this problem, how we are going to solve this problem using DFS. So I'm going to solve this problem using DFS approach. So what we have to do is, first we have to identify the first one. So we start from traversing from index this one 0, first index in the matrix, and then once we reach to this point, this is the 1. So we find whenever we find. So if my grid of I of j, if it is equals to 1, so whenever the 1 find, then I have to run a DFS to all, because from that one I have to connect every ones from this land which and all ones I can reach. So if I'm here, so I will run. So I already told there are four directions. So first direction is right, so I will take the right first, which is this one. Then I will take down call, then this is, then I will take left call, left is basically this is, and then I'll call up, and this is. So total four direction. So when I am here, when I am on this 0, first call is the right call. So DFS going to call to the right. So when he call the right, then he will find, okay, there is a 1. So means I can traverse on the land. So I can go here. From here, from this point, again I have to traverse to the right according to the DFS call. So when I go to the right, then I'll feel, okay, there is a 0. I cannot traverse on the water, because water I cannot go. So water or boundaries you cannot go. So you have to come back. So this, for this particular one, this call is done. I am coming back. Okay, and then next call, this right is done, then I'm going for the down. So this is coming for the down. Yeah, down there is a 1 already, so there is a 1, so this has to be considered. Then I will traverse to the again right, because as per the DFS, first one is the right call for each. So this all four call goes for every cell. So for this cell, now I'm going to the right, but right there is a 0, so this is done. I have to return it back, I cannot go further. Then there's a next is down. So for this cell I am going for the down, but down is again 0, again I have to return back. Then next is the left, on the left, so I have to go from this cell to the left, but left is again 0, again I have to come back. So again I am coming back, so left is also done. Then I am going for a up, so this is done. So when I am going for a up again, then there is a 1. So you will end up in the loop, go up, then come down, go up. So whenever you visit any cell, you just mark that cell as a 0. So for example, first time when I was here, I was going there, before going you mark this cell as a 0 or any other, because you don't want to visit 0, you don't want to go for the 0. And when I came here, again I marked as a 0. So then I came here, again I marked as a 0. So when you go up, then again you have to come back, because you cannot go up, because that is also 0. Now when you were traversing, you changed to 0, so you cannot go up. So this is also done. So now call for this particular one, all four calls are done. Now I'm going back up. So when we were at this one, first we made a call this one, this is we done, then we went down and we come up again. So these two calls are done. Now my recursion actually is going to start from the third one, which is left. So from here I have to go to left, but left is again 0 because you already marked as a 0. So then you have to come back, then you have to go up. There is a outer boundary, so again it is considered as an invalid, so you have to come back again. So this 4 call also done for this. Okay, then you will come back to the from wherever you came here from this one. So we came from this one, so you already made the one call, which is the right call for this one. Now you are going to make the down call. So when you go for the down for this is again 0, you have to come back. Then next is the left call, so you have to go for the left, but left there is also again a 0, again you have to come back. Okay, then you have to up is out of boundary, again you have to come back. Okay, then this all 4 calls. So the call is completed for this, and for this, and there is no remaining ones where I can traverse now using this one. And remember, now all the ones which I have already traversed, it becomes 0. So whenever you from high level you are going to call this DFS at the down, then you maintain their count. Okay, you run DFS once, so means the count is 1. Then again when you started, so again you find 1. So in the matrix, okay, this is 0, this is 0, this is 0, 0, 0, 0. When you come here, now you will get again there is a 1. So again apply the same DFS calls, write down up, and then whatever all the zeros are there, you make it all the ones are there, you make it them 0, and you come back, and then the second DFS call went, so it will increase by 1, so 2. So there will be total 2. So let's understand the code, and then you will get better understanding what I'm trying to say here. Okay, let's move to the call. Here first I am checking the corner cases where the grid, if it is null, or grid length if it is 0, then I'm returning itself. And then I am just getting how many rows and how many columns are there. And then there is one variable which I am going to return as a result, how many number of islands are there. And now we start traversing this particular matrix. So I am traversing here. So whenever I get 1, I am going to call the DFS. And whenever I go to call the DFS, if you see in the DFS call, I am checking the boundary conditions, if it is a boundary or if it is a 0. So if I am somehow by moving into the DFS, if I am moving to the 0 or I am moving out of the grid, then I have to return, because I cannot move there are not the valid positions as per the question. So then if it is not the case, then definitely there is a 1. So if there is a 1, then I am first making that 1 as a 0, and then I am making the further calls, which I already explained in the explanation. So then I am making these 4 calls, and this will make sure it will make all the ones to 0. And once this one DFS call is over, then you can increment the islands. Here I incremented number of islands before or after, doesn't matter, because if it is 1, then definitely there will be 1 island exist. That's the reason I already incremented earlier, but you can increment later also. It's up to you. And at the end I am returning how many number of islands are there in the question. So when we talk about the time complexity for this problem, so time complexity, I am running one loop for all the rows, one loop for all the columns inside this. So this is number of rows into number of columns is the time complexity, and I am not using any space. So space complexity will be order of 1 if we ignore recursive stack space. That's all for this problem. Please subscribe my channel and see you in the next question. Thank you.